Hello friends, I am Professor ANIL Brahmin from Sri Shankaracharya Technical Campus, and in this video we will explain calculation of volume in spherical coordinate system. In a spherical system, we are knowing any point may be elaborated by a radial coordinate r, which is the distance from origin towards the point, and the angle which this r makes with the z-axis, that is theta, and the coordinate phi, which is similar to the cylindrical system, in which this actually the projection of r, which is rho, is making with the x-axis. If you see the projection of r on the z-axis, it is r cos theta. But if you see the projection of r on the xy plane, it is a rho and it will be r sin theta. If we are considering a small volume in the spherical system as shown here, and if you see the enhanced diagram here, for understanding the volume in the spherical system, we must know the distances. In the radial direction, the distance, small distance, will be dr. But in this direction, in the direction of increment of theta, theta is the angle from the z-axis. So the distance will not be d theta, but it will be r d theta. It should be multiplied by r. But if you see in the phi direction, in the increment of angle phi, the distance will be, as we have seen in the cylindrical system, rho d phi. It should be multiplied by angle d phi, rho d phi. But rho in this case will be r sin theta, as we have seen here. The projection of r on the xy plane is r sin theta, which is rho. Thus, this distance will be r sin theta d phi. And now, here we have taken one example in which we are solving one problem in which the distance, this r1 is 2 and r2 is 4. The volume is bounded by these two radial distances. Similarly, the theta, lower theta is 30 degree, upper theta is 60 degree, and the phi lower is 0 degree, that means x-axis, and phi upper is 90 degree, that means it is y-axis. Thus the volume is bounded by these limits, and for calculating this volume, we must start with the small volume dv, which will be the radial distance dr. Then the distance in the phi direction will be rho d phi, and this rho must be equal to r sin theta. And the distance in the direction of increment of theta is r d theta. Thus, the small volume in the spherical system becomes r square sin theta dr d theta d phi. Now for calculating full volume, we are applying the limits, and if we apply the limits, r is ranging from 2 to 4, theta is from 30 degree to 60 degree, and phi is from 0 to 90 degree. And we have to calculate these integrations. R square dr first, then sin theta d theta, and then d phi. Now, one thing which we should keep in mind is this theta must be in radian. Then only our answers will be correct. So theta should be in radian, and we should, if we are using the calculator, we should keep the mode of calculator in the radian. And thus we can calculate these integrations. As we have seen, for r square dr it is coming out to be 18.6. For sin theta d theta it is coming out to be 0.366, and for d phi it is coming out to be pi by 2, and the total volume is coming out to be 10.69 unit cube. The main thing which we have to keep in mind is the distances r d theta and this rho d phi, which is equal to r sin theta d phi, and in that way we can calculate the volume in spherical system. Thank you.